Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue this new mini-series on core sizing. In this clip, we discuss failure of your product just above the core. I know your time is precious, so let's get started. In the last clip, we discussed some of the failures of the core itself. Please see that clip if you haven't already done so, because we build on those concepts here. In this clip, we cover failures of your product due to pressure and due to interlayer shear. Each layer of the web that you add to the winding roll adds to the pressure. As we learned in our Web 101 training, that pressure peaks near the core. That is one reason that you can crush the core. However, not only can you crush the core, your web product can also crush if it is not durable. However, what a lot of people do not know or consider is that there is another source of pressure near the core. That is the pressure due to the core lifting, holding, pushing, supporting the inside of the wound roll. In some cases, that core support pressure can be as great or even greater than those due to winding pressures. In my award-winning and trademark Web 101 class, we show how to predict those pressures due to winding and those due to core support. So, what harm might these combined stresses do to your web product? You can have permanent losses in bulk or thickness that range from negligible to crushing. This is especially troublesome for products such as nonwovens, where bulk is desired for absorbent capacity as well as insulation. Worse yet, since the pressures are highest near the core and zero at the outside, the caliper coming off your customer's unwind will vary from crushed near the core to undamaged near the outside. In short, your web product is unevenly crushed. Another well-known pressure-related damage is blocking. That is where the layers stick together too aggressively. We've all had adhesive tape that would tear because it's stuck together too much. That can also happen to plastic film, coated products, printed products, and many others. Because the pressure is highest at the core, the blocking will be worse there and less elsewhere. This is a TTP problem, time, temperature, and pressure. The winding part is the easiest. Wind as loose as possible, particularly near the core. After that, you may need to redesign your web using DFM, Design for Manufacturability, which in this case means designing a web that can withstand normal winding pressures. You may also have to limit temperatures that might approach 160 degrees Fahrenheit during transportation. While all of this may seem to be overkill for wound rolls, temperatures is closely controlled for food products, and thus we can take inspiration and technologies from them if winding loose and DFM together are insufficient. Another factor in compressive stresses is the deflection of the core in the wound roll. Here we show that the core support pressures may be greatest near the ends. From the same uneven pressures, we can also have uneven interlayer slippage, which can cause rare but devastating wrinkles and tears on your products. Both insults are extremely sensitive to your choice of core diameter and core length. In our Web 101 training, we showed how to draw a J line on the side of the roll to diagnose some winding defects. The J line is a direct measure of the severity of interlayer slippage. Tools like this are necessary, for example, to determine which of the 10 types of telescopes that you have. The most common is type 1A, shown here. However, there are many other defects that can result from interlayer slippage near the core, including tears and wrinkles. To further complicate the mechanics, some of these defects are torque-induced and some are roll weight-induced, and the direction of slippage is different for each. Thank you so very much for joining me in this problem-solving and problem-preventing series based on optimum core sizing. Stay tuned for the next clip where we will talk about the dimensional stability of fiber cores and the failure modes that can result. If you found anything interesting or useful here, please like and share and subscribe. See you next time.